Okay, so let's talk a little bit more about this phase of follicular development in the menstrual cycle. So this diagram looks a little complicated, but I'm going to take you through it step by step. It is actually kind of useful in my opinion. It emphasizes the development of the primary follicle through the secondary follicle to the dominant antral follicle just before ovulation. Okay, so this is the phase that we're talking about. Once again, so we start at number 1 here, where we have FSH acting on granulosa cells, and FSH stimulates the production of estrogen by stimulating aromatase. Okay, so we've got increased estrogen production through the auspices of FSH here. The estrogen in step 2 here does 2 things. First of all, the local estrogen, through an autocrine mechanism, feeds back and binds estrogen binding sites at the granulosa and increases the proliferation of granulosa cells. Okay, so this tends to make you want to make more estrogen, because more granulosa cells means more production of estrogen and more secretion, right? At the same time, the second thing that happens is you have this negative feedback on the hypothalamus and the anterior pituitary that I've talked quite a bit about already. Okay, so we have 2 things, and it's a tug of war between the 2 going on during this follicular development. We have estrogen trying to make more of itself, and at the same time we have estrogen decreasing the production of FSH, which tends to decrease estrogen production. Okay, and what happens is between the 2 of these things, you end up with a reasonably stable level through much of the development of the follicles. Okay, we also have FSH acting along with estrogen on the granulosa cells. And this increases LH receptors, and I'll show you this pathway in a moment, but LH in granulosa cells causes production of progesterone, which is a precursor for androgen, which is a precursor for estrogen. At the same time, we have LH acting on the theca cells to increase androgen production. That feeds into the production of estrogen, because they're precursors for estrogen, as I showed you a little while ago. And so that increases estrogen production. Okay, so we have all these things that tend to increase estrogen production, and they're kept under control by this negative feedback on FSH. Okay, but the granulosa is proliferating. The potential to secrete estrogen is there, and the potential increases and increases and increases. All right. Here is our production of progesterone from cholesterol under the auspices of LH. Progesterone goes to the theca interna, and the thecal cells convert that to androstenedione. And then the androstenedione, or the androgens, go back to the granulosa cells. And we also have androgen being produced by the thecal cells, of course, under the influence of LH here. And then that androgen all goes back and feeds in to make estradiol on the granulosa cells. Okay? All right, so we have these granulosa cells that are proliferating. We have this follicle. It's getting bigger and bigger, and the potential to produce estrogen is going up and up and up, and the FSH is keeping it under control because of the negative feedback, and this is going on all through the development of the follicles, and you've selected your dominant follicle, and now all of a sudden you get this point where the potential to increase estrogen apparently overcomes the negative feedback on the FSH, and you get this big increase in estrogen. We'll see it later on in the lesson. Right toward the end of this follicular development period, the estrogen goes up, okay? Because the potential, all these factors that increase the production of estrogen eventually overwhelm the negative feedback loop. You get this increase, okay? And if the increase is high enough and long enough, about 2 days, what happens is ovulation takes place, because the estrogen converts, the high estrogen converts the normal negative feedback into a positive feedback, particularly on the hypothalamus. We'll talk about that in a little while, okay, in the next phase of this lesson. But this is where ovulation takes place. The estrogen goes high enough for long enough, you get positive feedback here instead of negative feedback, you get a surge of LH, and that causes ovulation, okay? And there it is, resulting LH surge, because you've stimulated your hypothalamus to secrete a whole bunch of GnRH, and you get this huge LH surge, and that results in rupture of the follicle on ovulation, okay? It just precedes it, okay? So, the LH surge, what does it do? Here is the pathway. You see here, it acts through cyclic AMP and protein kinase, similar to some of the other hormones that we've talked about, and acts through protein phosphorylation by protein kinase. What you get as a consequence of this is completion of the first meiotic division. Okay, so remember, we have our oocytes, they're all lined up at the start line, and in your mature follicle, the LH surge takes place, the first meiotic division completes, okay? You complete that, you form your first polar body, right? And there it is, formation of the first polar body. We have meiosis is again arrested, the second meiotic division, okay? And ovulation occurs, all right, as a result of the LH surge. So what's the LH surge doing specifically? It initially, there's an increase in estrogen, and that is followed in androgens, and that's followed by a decrease. We'll see that. We'll see the decrease in particular in a minute when we talk about the changes in hormonal levels during the cycle. But estradiol goes down as a result of this surge, progesterone goes up. The granulosa cells begin secreting progesterone, and the process of luteinization begins. We'll talk about that in a minute. And the progesterone increases the production of enzymes that produce prostaglandins, which are involved in the process of ovulation. We'll talk about that in a minute. Neutralization of oocyte maturation inhibitor, that's what OMI stands for. We aren't talking a lot about this. You won't find a lot about it. So I didn't think it was worth emphasizing, but it's playing a role in suppressing that first meiotic division and keeping it in stasis. So you neutralize this oocyte maturation inhibitor and the first meiotic division completes, okay? It plays a role in allowing the first meiotic division to complete, okay? We have our prostaglandins here, these do two things. They activate collagenase, which weakens the follicle wall, and they increase blood flow, which causes the follicle to become hyperemic, and it swells. And it actually bulges out of the side of the ovaries. So this follicle is literally at the side of the ovary. If this is the wall of the ovary, it's actually bulging out. Some of you know I was trained as a veterinarian, and I've actually done this. You can actually, in large animals like cattle, stick your arm up into the rectum, into the large intestine, and you can feel the ovary, and you can feel these follicles bulging out of the side of the ovary, and you can actually make an estimate of what stage of the cycle the cow is in by how far out it's actually bulging. Okay, so we're bulging out of the ovary, and we have our weakened wall and our swelling, and this results in follicular rupture, and the oocyte literally leaves the ovum. Technically, it enters the abdominal cavity, but it's a release of the, quote, mature ovum. It is arrested partway through the second meiotic division. The fimbria sweep that ovary into the oviduct, okay, and don't allow it to be secreted into the abdominal cavity itself. And you get the process of luteinization taking place as well. The LH acts on what's left of the granulosa to produce corpus luteum, that is cells which are particularly good at secreting progesterone and some estrogen, and this is the primary source of these hormones during your luteal phase of your cycle. And the preparation of the uterus for implantation is actually taking place before this. It's taking place during the follicular phase. The estrogen causes proliferation of the endometrium in the uterus, but the progesterone during this phase stabilizes it and keeps it stable and prepares for the process of implantation should fertilization take place. If pregnancy does not occur, then the corpus luteum regresses and it becomes a corpus albicans, and it's basically a scar on the surface of the ovary. And that may take place because LH levels eventually fall to a low enough level to where the corpus luteum can't be sustained. It is sustained if pregnancy occurs. We'll talk about that when we talk about pregnancy in another lesson. Okay, so let's go through the cycle again, and let's talk about it in terms of what's happening with the hormones during the cycle. And we'll correlate that back to the follicular level as we go through, although I think you guys have an idea of what I'm going to show you based upon what I told you about the follicles already. So here is our negative feedback. Here is our hypothalamic pituitary gonadal axis in the female. We have the hypothalamus here. It is secreting GnRH. GnRH is acting on the anterior pituitary to cause release of our gonadotropins, FSH and LH. These act on the ovary, or gonad, and that results in the production of estradiol. And estradiol normally feeds back in a negative manner upon the hypothalamus and the pituitary. Okay, we also have release of inhibin during this follicular phase, actually after the follicular phase, and that feeds back on the pituitary and keeps FSH under control. It helps keep FSH low, and I'll show you the effect of that in a moment. And we also have activin. Now, we aren't going to talk a lot about activin because, frankly, not a lot is known about it. It stimulates the release of FSH, okay? It's probably most important during the follicular phase. It probably is what's causing what we're going to call the FSH surge. The FSH surge takes place at the same time the LH surge does, but it's smaller and not as significant, okay? And really, that's just about all we're going to say about activin. I wouldn't worry excessively about it except for those facts. Bear in mind that this feedback is negative, but it is going to become positive at some point during the cycle, right before ovulation, and that's going to cause a big surge of estrogen, okay? A big surge of LH, okay? And that takes place primarily because of the change in the feedback on the hypothalamus, at least as far as that's known. So these are the hormonal changes during the cycle. Notice that this is real data. These are error bars, which indicates the variance in the hormonal levels in the population that they took the samples from. This is different from what you'll see in most textbooks, which are cartoons, and I'm going to show you a typical cartoon later on in this lesson, though I won't emphasize it. On the bottom here, we have our gonadotropins. We have LH in the open circles. We have FSH in the closed circles. Here's our LH surge and our FSH surge. We have progesterone and estrogen, estradiol here. Progesterone, open circles, estradiol, closed circles in the middle. And then up here, we have inhibin. Now, there is an inhibin A and inhibin B. Inhibin is actually a dimer, and whether you are an A or a B depends upon what subunits, that the dimers have. We are not going to distinguish between the two, at least as far as the physiology is concerned, except to point out that inhibin B seems to be most important in the male. Other than that, we won't distinguish between them. Inhibin, again, involved in keeping FSH low, so FSH relatively low here and here before and after ovulation. Inhibin very involved in keeping that under control. Okay. Then here is our estrogen surge from our dominant follicles. Remember, I was talking about the fact that you get this increase in estrogen for a couple days right before the LH surge. So this is the highlight of our the culminating event of our follicular phase of the menstrual cycle here. This increase in FSH. Okay. Once again, you know, this estrogen is evoking your LH surge, okay? If it's high enough or long enough. The mechanism by which this takes place, I won't say it's greatly understood, but the hypothalamus apparently loses its sensitivity to dopamine and endorphins. So ordinarily you have this tonic inhibitory action of dopamine and endorphins, and they keep the release of GnRH under control. And apparently, at least partly, what happens is you lose the sensitivity of these to these dopamines and endorphins. This negative effect goes away so that you can increase the release of GnRH, and that will increase the release of LH. So that, at least partly, is what takes place here, okay? And then post-ovulation, we enter our luteal phase. Follicle becomes a corpus luteum, of course, and this, again, increases the release of progesterone from the cells, and estrogen is still released at a fairly low level. And that results in the hormonal changes that you see.